In the heart of every black hole lurks an unspeakable mystery. What secrets are sealed inside that ultimate point of no return? Their gravity is so powerful that nothing, not even light, can escape once it crosses the invisible boundary called the event horizon. But what actually lies within this cosmic trap? Today, let's unleash our imagination and explore the wildest possibilities out there. One of the most astonishing ideas is that every black hole might be a gateway to a brand new universe. Picture it. Matter collapses in on itself, hurtling inward until it can go no further. Then, in some alternate dimension of space-time, it explodes outward in a big bang, creating an entirely separate universe. It's a mind-bending concept, baby universes growing in the dark womb of a black hole. If this is true, then our own universe might be the result of just such a cosmic event. Another strange possibility rises from string theory, which tells us that inside a black hole, instead of a single point-like singularity, we may find something called a fuzzball, an immense tangle of vibrating strings and brains. Here, the usual concept of empty space disappears. Instead, everything is woven into an energetic quantum tapestry, a cosmic hairball of fundamental strings. You wouldn't so much fall into this place as merge with its endless vibrations, leaving our normal definitions of space and time behind. Then there's the bag of gold scenario, where you enter a black hole that seems small from the outside, but once across its threshold, you discover a vast, ballooning world hidden within. Inside this bag of gold, space-time itself could stretch out into a near infinite domain, cramming enormous volume behind that deceptively small event horizon. In essence, it's like stepping through a tiny door into an endless realm. Digging even deeper, some theories suggest that near the singularity, all of space-time breaks down into a turbulent quantum foam, a realm of constant, frothing activity at the very smallest scales. In this seething chaos, distances and time intervals become meaningless. The laws of physics as we know them might disintegrate, replaced by fleeting wormholes and tiny tunnels that appear and vanish in fractions of a second. Speaking of tunnels, there's a favorite from science fiction: wormholes. In some visions, the center of a black hole could connect to a distant region of the universe, or perhaps another universe entirely, via an Einstein-Rosen bridge. Theoretically, you'd be launched onto the other side of space-time. Surviving the journey would be questionable. But if somehow stable, this cosmic shortcut might instantly whisk you across incomprehensible distances, or even into a parallel reality. Next, a far more ominous hypothesis: a firewall. According to this idea, the event horizon itself might be an inferno of high-energy particles, vaporizing anything that dares to cross. If firewalls exist, then the interior of the black hole is effectively off-limits. No gentle passage, just a violent boundary between our universe and the unknown. Finally, we come to the holographic principle, which suggests everything falling into a black hole might be stored on its two-dimensional surface, rendering the interior a kind of cosmic illusion. In this view, that vast interior is just a projection, a hologram shaped by quantum information shimmering on the event horizon. Could the inside of a black hole be nothing more than a 3D manifestation of data? Of course, even if we found a way to slip past the event horizon, there's another unescapable truth: gravitational time dilation. The closer you get to a black hole, the more intensely your time slows compared to the rest of the universe. From your perspective, everything might seem normal, but outside, years or even millennia could pass in what feels like moments to you. By the time you tried to send a message home, entire civilizations could have risen and fallen. Your friends, your family, anyone you hoped to tell, they'd be long gone. So, even if you somehow survived and made a miraculous discovery inside, by the time you emerged, there would be no one left to receive your astonishing news. Here, we see one of the most groundbreaking images in the history of astronomy, the first direct visual evidence of a black hole's silhouette. Though it appears as a fuzzy, glowing ring, make no mistake, this is the edge of a cosmic giant at the heart of the galaxy M87. Captured by the Event Horizon Telescope and shared by NASA, it's a triumph of global collaboration and technological ingenuity. In this blurry donut lies the supermassive black hole's event horizon, a boundary from which no light can escape. At 55 million light-years away, this black hole is gargantuan, about 6.5 billion times the mass of our Sun. This single image gave us our first real photographic proof of the most mysterious objects in our universe. But there's more to M87's black hole than just that iconic close-up. Take a look at this image from the European Southern Observatory's Very Large Telescope. If you look closely at the center, you'll see a brilliant, narrow jet shooting outward. This powerful jet is launched from the black hole's accretion disk, an extreme torrent of high-speed particles spewing from the galaxy's core at nearly the speed of light. It's a stunning reminder that black holes don't merely consume, they also energize and transform their surroundings on a galactic scale. Together, these two images encapsulate the scope of black holes, from the immediate shadow of the event horizon to the vast, relativistic jets that can stretch thousands of light-years into space. They remind us that these cosmic titans are anything but simple. Each snapshot, fuzzy or otherwise, carries within it the story of an entire galaxy. We stand at the edge of the unknown, with theories that verge on science fiction, yet they're built on the pillars of advanced mathematics and quantum logic. For now, black holes remain the ultimate enigma. But one thing is certain: each new insight reveals that our universe is far stranger and more magnificent than we ever imagined.